Okay, let's look at some functions. So figure 2 shows a sketch of part of a graph with equation y equals f of x, where f of x equals 21 minus 2 modulus 2 minus x, domain x is greater than 0. Find f of 6. So for f of 6, we just replace x with 6. So that's 21 minus 2 modulus 2 minus 6, which is 21 minus 2 modulus minus 4. Modulus minus 4 becomes 4. So that's 21 minus 2 times 4, which is 8, and then 13. Solve the equation f of x equals 5x. So first things first, we make a plot. We always start with a plot, and you have your modulus graph on the same graph as your straight line. So if I've done this on numworks here, and you can actually see the answer already. So I know I'm looking for 3.5, which is nice because you can check whether you've done it right or not. You have to label both branches of the modulus, because obviously on one branch the modulus will be acting, on the other it won't be. So if we actually look at our modulus, I have 2 minus x. So my modulus will be negative to the left of this point here, where x equals 2. So for example, x equals 3, that becomes minus 1 and the modulus is acting. So all along this second side of the modulus here, the modulus is acting. So the sign is being flipped, so we multiply it by minus 1. Which becomes 21 plus 2, 2 minus x, while on the other side the modulus isn't acting, so the function is exactly as it's seen with no changes. But now that I know that there's an intersection here, I just solve this linear equation the normal way. So I have 5x equals 21 plus 2 minus x, and we just solve this equation, hopefully. So 21 plus 4 minus 2x, so I have 7x equals 25, x equals 25 over 7. Now I know from my calculator that should be 3.5, so if it's 3.5 then we're right, and if it's not then we have to 25 divided by 7, yeah, 3.5, good. So we know we're right, which is nice about these questions. Cool, good. And then what else does it want? Given the equation f of x equals k, where k is a constant, has exactly 2 roots, find the set of possible values for k. Okay. Okay. So if something is just f of x equals k, that's like the equation like y equals 3. You know what I mean? It's just a straight line. So if there's 2 solutions, it's going to be a straight line between these 2 points. So any of these straight lines will give you 2 solutions. So the range of values for y will just be between this point here and this y coordinate here and this y coordinate here. So we need the y coordinate of the vertex and where x equals 0. So the vertex, we know x equals 2, so I'm going to evaluate my function here. I'm going to take f of 2, it's going to be 21 minus 2 times 2 modulus, 2 minus 2, which is just 0, so that's going to be 21. So that is y equals 21. And then we've got to find this one. That's going to be the function evaluated at x equals 0. So I have 21 minus 2 modulus 2 minus 0. So that's 21 minus 2 times 2. 21 minus 4 is 17. So k can be between 17, that's y equals 17. K can be between y equals 17 and y equals 21. Any straight line in that region will give 2 solutions. So we have 17, k, 21. Okay. The equation with the graph with the equation f of x is transformed onto the graph with the equation f of x minus b, a f of x minus b. So it's been shifted to the right by b, and it's been stretched by factor a. So the vertex is now 6, 3. Find the transformation. So we know the vertex originally, so this is f of x. So on f of x, and then f of a, f of x minus b, it's become 6, 3. So my vertex was at 21, 2, right? So we can see how far has it been shifted along up the x-axis. Well, it's been shifted 4 up the x-axis, so b is going to be 4. And then my old y-coordinate has been multiplied by a to get 3. So I know 21 times a equals 3. A equals 3 over 21. So I think my new function is 3 over 21 f of x minus 4. Cool, and we can check that on Desmos if you were so inclined. Right, here we go. We'll do this one, then we'll do the other one. One more. So let's have a look. Figure 1 shows a sketch of the graph with equation y equals f of x. X is real. A graph consists of two half lines that meet at the point. Okay, whatever. The graph cuts the y-axis at 0. So this is basically, we have the graph. Y equals modulus of x. What this is actually performing the modulus on is the actual argument that's going into the function. So what it's saying is when I'm trying to pass in negative x values, they become positive. So what you basically have is the positive region of the graph is repeated a second time over on the other side. So you have something like this. So it's just a reflection and a deletion. So that goes. So you can work out these points. I think it wants us to plot all the points. Yeah. So it's a reflection. So if that's at 2 minus 3, that's going to be at minus 2 minus 3. If that's at 5, that'll be at minus 5. And I think that's it. So that's that first one. Being slightly arrogant and just ticking my answers. 2f of x plus 5. Okay, so we always do the transformation that's closest to the x first. So we're going to do this plus 5. So each point is going to shift 5 to the left. So this 5 is going to be here at 0, 0. This minus 1 will be over here at minus 6. And this 2 minus 3 will shift 5 this way. So 2 minus 5 is minus 3 minus 3. So this is, let's just keep the axis going. So that's f of, oh golly, didn't want that. F of x plus 5. And then 2x plus 5, each of my y values gets doubled. So let's go green. So 0, 0 stays the same. Minus 6, 0 stays the same because they've got the 0 y coordinate, so the y coordinate stays the same. And then that'll be minus 6. So that'll be minus 3, minus 6. So that is 2f of x plus 5, I think. And then it wants point P, which we already did. There you go. Cool. Last one. Given that f of x is 3x plus 5 and g of x is 1 over x, find f to the minus 1 of x. Okay, so what we do is we set that equal to y. So I say y equals 4 over 3x plus 5. And then we're just going to rearrange for x. So I'm going to times both sides by 3x plus 5. So I have y times 3x plus 5 equals 4. So then I have 3x plus 5 equals 4 over y. And then I have 3x equals 4 over y minus 5. And then I have x equals 1/3 times 4 over y minus 5. So x equals 4 over 3y minus 5/3, which looks like a very horrid function. F to the minus 1 of x. I was going to say it's right. You might have to check me on this one. 3y minus 5/3. Okay. State the range. Got to read the question, man. Got to read the question. Okay, so with the range, we're going to plot this, and we're going to look at this domain, and we're going to figure out that range. So 4 over 3x plus 5. 4 over 3x plus 5. Let's delete what we got here. Delete, delete. 4 over 3x plus 5. Plot x is bigger than 0. So let's have a look. So when x is at 0, so when x is 0, y is 0.8. And then as x increases, y just decreases forever and ever and ever and ever and ever. So the highest y value the function can have at 0 is y is 0.8. So we're going to say 0.8 is, so the function is smaller than 0.8 and it's also bigger than 0. It never quite reaches 0. So we've done that. F of g of x. So we've got to do, got too many scribbles here. So let's just erase that. F of g of x, I've got to take g of x, and then everywhere where there is an x in f, I've got to replace it with g. So f g x is going to be 4 over 3, instead of x, it's going to be 1 over x plus 5. So that we can just 4 over 3 over x plus 5. Could times top and bottom by x just to make that kind of neater. So we go 4x. So what I'm doing is I'm saying times by x. I'm saying times by x. So I got 4x over 3 plus 5x f of g of x. 4x over 3x plus 5x. That seems right. Show that f of g of x and g of f of x has no solutions. So we've got to find g of f of x, which is going to be the opposite way around. So everywhere where there is an x in g of x, we're going to replace that with blah, blah, blah. So that's 4 over, it's going to be 1 over, brackets, 4 over 3x plus 5. So let's just flip that round. So that's 3x plus 5 over 4. And then what we're doing is we're showing, we might stop there, but we're showing that these have no solutions. So this should have a discriminant less than 0 when we come around to solving this. So 4x over 3 plus 5x equals 3x plus 5 over 4. So timesing both sides by 4, if I multiply both sides of the equation by 4, I have 16x over 3 plus 5x equals 3x plus 5. And I'm going to multiply both sides by 3x plus 5, 3 plus 5x, so that's 16x equals 3x plus 5 multiplies 3 plus 5x. So now 16x equals 9x. I'm expanding this now, plus 15x squared. So that's 9x plus 15x squared plus 15 plus 25x. Yeah, 4 times 5 is 25. So then I'm just going to write it this way around because it seems neater to me. So 15x squared. 9x, 25x is plus 34x plus 15 equals 16. So then take 16 away from both sides. I have 15x squared. 34 minus 16. Home. Calc. 34 minus 16. 18 plus 18x plus 15 equals 0. We can divide this whole thing by 3, I think. So that's 5x squared plus 6x plus 5 equals 0. So then it should hopefully be that if I go A, B, C, it should hopefully be the case that b squared minus 4ac is less than 0. So we've got to kind of keep our fingers crossed here. So 6 squared minus 4 times 5 times 5. Is that less than 0? Let's hope so. So that's 36 minus 4 times 5 is 20 times 5 is 125. Cool, less than 0. So 36 minus 125. 36 minus 125 minus 89. Minus 89. 89 is less than 0, so no solution. I can't spell. Solutions. Alright.